Hello and welcome to the session on how Amtrak is using AWS to improve the rider experience. My name is Brett McMillan, Director of AWS Federal Civilian Sales. Amtrak is America's railroad, and they serve 32 million riders each year. It's a great experience. If you've never ridden Amtrak, I would highly recommend it. I ride it on the Northeast Corridor, and in the Northeast Corridor, they run over a 90% passenger on-time experience, and it's safe. It's many times more safe riding on Amtrak than it is driving to the train station. And they have a best-in-class 84% customer satisfaction. Amtrak just recently celebrated their 50th year anniversary. They were created by an act of Congress 50 years ago, and they're continuing to grow strong. Today, Amtrak is serving over 500 communities, but they've got expansion plans. They're going to, by 2035, serve an extra 160 communities. And when they're serving these additional communities, they will grow from 32 million to well over 50 million customers served. Amtrak has been continuing to iterate. They have a great customer experience. And shortly we're going to hear from Shrikant Ektari, who's the Senior Director for Cloud Solutions. And he is taking the vision of digital and turning it into execution and reality. Let me hand it over to Shrikant.
Thank you. Thank you, Brett, for the introduction and this opportunity to share Amtrak's accelerated cloud adoption journey, and also opportunity to listen to my peers, industry peers, and summit attendees about their stories and their lessons learned. So hello everybody. In today's short session, I will walk you through our cloud adoption journey to the cloud maturity. And we will take a couple of real life use cases. These use cases are in production and about our operations and mission critical systems. Then we will talk about some in-flight initiatives. We will take a deeper dive into technical areas as and when we need it, and share some Amtrak's cloud ecosystem overview as well. So with that, let us take a look at the journey itself. It's a bimodal IT. So when I use the word bimodal, I mean the mode 1 and the mode 2. The mode 1 is our conventional 2-tier, 3-tier IT systems that we are used to. And the mode 2 is our cloud native development, the microservices based development, where the systems are here developed in cloud, they run in cloud, they monitor in cloud. So two modes of cloud, two modes of IT, bimodal IT. And it started around 2012 and 13 when Amtrak's internal cloud evangelists were, these are very passionate technical people. So they tried AWS pilot to production on SAP's non-production systems. As you might know, that SAP is an involved comprehensive landscape with NetWeaver architecture, ECC, BW, process integration. And this team was very successful in standing a non-production ecosystem of SAP in AWS. What gave was confidence and the trust. It gave trust in the people who are executing this. It gave trust in the process and the trust in the platform itself. When you run a financial system of record, even though it is non-production in cloud, that builds interest and trust. Then there was this organic growth over several years, and where we migrated close to 150 applications to AWS, started cloud native development with microservices-based architecture, serverless architecture, integration platform as a service was introduced. I think the whole organization was technically and process oriented, was in a very fast pace adoption growth. And eventually around 2019 and mid 2020, we could sunset a large data center to us, that was a big deal, both from the cost perspective and also for the resiliency and SLA perspective. With that data center sunset, today we run our mission critical workloads, and we will take a look at some of them in cloud today. They are core financial system, planning, consolidation, our GL. We also run customer facing mission critical application in cloud. And in around last year, when we had COVID pandemic, once again we realized that time to build, time to deploy, time to market with this whole cloud serverless system is really fast. When we could roll out desktop as a service using workspaces, that was very productive for our remote employees, business partners. And currently, as I speak, we run a program what I call as a Cloud 2.0 initiative that covers automation, multi-account adoption, adopting infrastructure as a code, implementing disaster recovery, cross-region resiliency, and some interesting DevSecOps practices with networking constructs using transit gateways. Lots of things happening. And in today's next 20-25 minutes, I will cover use cases based on one or two of them. So let us take a look at the technical ecosystem of our cloud. So what you see is 5 to 10,000 foot overview of a cloud ecosystem. And I will start from the left to right. On the left, we have 3 AWS regions, US East 1, East 2, and the US West. This is where our assets are distributed. And on the far right, we have our on-prem assets like mainframes. The communication between 3 AWS regions and backend happens through cloud exchanges. And as you see, we have 2 Equinix exchanges, regionally distributed. In addition to this, there is integration platform as a service which communicates with external SaaS application and our cloud ecosystem. And again, there comes transit gateways that helps us reduce the spaghetti-based point-to-point integrations. This simple looking architecture is a interesting and very robust network engineering work done by our network engineering team. And in my subsequent slide, I'm going to touch upon one such section of this network engineering. So this is a technical overview of the landscape. Now let's take a look at what I call as a governance. From my experience, we can say that technical maturity and technical, ecosystem alone is not adequate unless it is supported by a strong governance structure. And we at Amtrak have a strong executive support and involvement. Support alone doesn't work, so we also have executive involvement in the processes. And then there is a matured collaborative governance between solution architects, engineer, network architect, development team, security architects, and the cloud services team. And what this governance structure does is we serve our internal vertical customers. So this customer, for example, could be corporate system customers like finance. Customer could be marketing, running omni-channel programs in cloud, SLR 21 program, and of course, the security. We at Amtrak have a zero trust security. And essentially what we believe is security delegated is diminished. So we personally run our security systems with detective and preventive controls. All these vertical customers are served through the cloud layer. That includes the IaaS layer, the platform as a service. That includes more than 50 AWS services, including relational, non-relational, serverless, compute, and they are tied with very tight compliance, access control, network isolation. So each of these are work stream within cloud. And even if this governance structure work, for us, the real test is the cost effectiveness of this whole thing. So we have a dedicated work stream that looks after the cost management, the cost control, the chargeback model, the showback model, OpEx at a program level, and continuous right sizing. So once again, the technical maturity and the governance maturity both are needed when you run large transformational programs in the cloud. Now let's take a look at a use case of a cross-region resiliency or a DR. So the business case is very simple. For our customer safety and accident prevention, we have a system called as a positive train control system. This is an ecosystem in cloud that must be available 24/7. Before a train initializes, it needs some information to implement safety and security standards. That information is about the train itself, which we call consist data, and some employee data. So positive train control system, the example that I'm going to cover, offers cross-region resiliency to 19,000 train miles of journey. How significant it is. So now the question is, why should it be cross-regional DR when you know that a single region in AWS can give you adequate resiliency and through their AZs, and we use that. So even if you have a regional resiliency and regional SLAs, which are quite satisfactory, what about the telecom outages outside AWS control, which actually had happened? So there was a telecom outage a couple of years back, unrelated to our cloud ecosystem, that led us to implement the cross-regional design. And this entire solution, as we will see in details, from build to monitor, is resilient at every layer. So at, again, very high level, the architecture of this cross-region resilient PTC would look like this, from left to right, from train to wireless networks to Rockwell Collins to two AWS regions, US East and US West, through Route 53. How this happens, where the magic is, how these two layers in the East and the West are identical. Let's take a deeper dive again in under the hood architecture of this implementation. So what is under the hood? Now we are getting into some technical details of this architecture. It is not just a DR solution. It is active load balance cross DR solution. What it means is, when a request from a train comes to Route 53, it has 50% weighted average routing, where half the request goes to the East and the rest half goes to the US West. So it is again load balance, active. Each region has AWS Beanstalk based implementation, and Beanstalk essentially is a platform as a service. It gives us auto scaling, load balancing, health checks, very easy to deploy, develop. It is self-managed. Now what about the data itself? We use global DynamoDB tables, cross-region replicated. So our persistent storage replicated, our traffic replicated, and build to monitor again is in AWS. Let us take a look at our reference architecture. See, as we go from, in this story, we are going from 10,000 foot to 5,000 foot to details. so that we are giving you the context and underlying technology. So here you will see a request goes to Route 53. Then there are two regions, east and the west. Each region is identical, like a mirror image. So the code deployment, the DevSecOps practices make sure that code is identical in both the region. Now let's take a look at within each region here. Within each region you will see a multi-AZ based deployment of application on Beanstack. Again, same in both the regions. As far as the data is concerned, we are using DynamoDB multi-master replication with eventual consistency. So at any given time, our databases in DynamoDB are in sync. Again, it's a eventual consistency, and for this application workload, this works fine. So this is the build part, this is the run part, this is the deployment part. Now, how about monitoring of this solution? The monitoring of DR components is again at each level, starting right at Route 53 health checks, CloudWatch, which is natively integrated with Beanstack, natively integrated with DynamoDB tables, comes to your rescue when it can monitor the events in this application and the database. In fact, it can also give you very nice metrics to see the performance, what is happening. Integrated with that is email notifications and alerts that are monitored 24/7. And any issue results into what we call as a severity 1 response. This being customer facing mission critical safety application requires a severity 1 response. What is a severity 1 response? We at Amtrak have a dedicated, very effective incident response organization. And that organization can stand up all hands on deck, a response team, if anything is noticed out of ordinary. So what we just saw here, to summarize this business use case and the technical use case, is a mission critical customer facing operationally significant application offering cross-region resiliency, data replication, security, encryption, monitoring, build, all consistently with AWS services. So this is what the summary of this use case was. Now, speaking of monitoring, in addition to such cross-region resilient system, we monitor the entire cloud ecosystem, and what we call that as observability. So observability has many dimensions, not just monitoring of servers and databases and applications. It also provides you an ability to visualize the events, including the business transaction events and technical events. And it also includes a log analytics on the ELK layers. And there again, we have AWS managed Kafka integrated with ELK. And in addition to monitoring log analytics and visualization, if project teams need a transactional tracing and analytics based on needs of a project, you get a transactional tracing abilities to look at the response time, the rates, the volume, etc. Very comprehensive enterprise class observability framework using native agents and offering a broad umbrella view. Now I am taking you into some very advanced cases of cross-region resiliency. The use case that we saw, although mission critical was entirely on one platform, we also have systems that run across cloud platforms. They are microservices based application they run through iPaaS layer, they go to third-party systems, they run in AWS. Now, providing resiliency to such applications is an interesting word. And foundation of that is infrastructure as a code, DevSecOps practices, and some services which are offered by AWS, which we are going to take a deeper look again here. And even if technically everything is feasible, there is again a cost consideration. Does this system really need active-active? Or can warm standby be okay? So these are some factors we evaluate. Evaluation leads to a discussion on scorecard. The disaster recovery microservices based application scorecard. So here, the actual scorecard that we use is actually 50 to 60 different criteria. What we are seeing here are three critical lenses: the platform scope, the persistent storage scope, and the networking scope. For the platform storage, again, is it single platform, multi-platform? And if it is multi-platform, does each platform has DR capabilities? On the persistence, we need to factor in the relational databases. Can we use Aurora global databases? Can you use RAID replica cross regions? No SQL DynamoDB, we just saw a use case, it works fine. And very critical is AWS backup service, which allows us to manage the backup of EC2 images, other storages based on the tier of an application. The tier of an application is it platinum, gold, silver, bronze, and what should be the frequency of backup cross region? That definitions are made here. And even if your two layers are fine, what about the networking itself? Do you have single cloud exchange location and a single point of failure? Do you have just one DNS or you have combination of DNS? Lots of interesting things. Again, this slide is 2 or 3 hours of discussion. Let us take one more very interesting use case, which is adoption of multi-account structure and automation. For those of you who started cloud 5-6 years ago, might know that there was no such thing as multi-account. So we also had a single account when we started, where all our assets are segregated based on the landscape, on the VPC segregation techniques. It worked fine. There's nothing wrong in that. But as we organically grew and our footprints and assets in cloud grew, we were running a risk of a large security blast radius, and anybody would. In addition to that, there are capacity limitation that one would face, like running lambdas in a concurrent mode that in development that can eat up your capacity, and so on. So there are reasons why you should consider multi-account structure. So today what we have is landscape-based multi-account structure, such as production, non-production, test, development, these accounts, and they are served by a common shared services account like infrastructure account, networks account, and security accounts. And you will also see it gives us an ability to have a control tower where we can have a predefined guardrails. These guardrails could be detective, these guardrails could be preventive in nature. They help us find out the security drifts, if any. Security drifts such as every volume must be encrypted, but there is a drift in one account. So this is a multi-account structure, and I will take you a deeper dive into what happens in this network services account for such structure. So this is a network services account that serves all accounts. So we have 3 types of traffics: all inbound, all outbound, and within our corporate networks. The beauty of this network design is there is a central place to inspect, monitor, log, put through firewall, one place. And through this, you can easily implement a firewall of your choice, be an AWS firewall or third-party firewall, and the rules are applied here. So instead of having several internet gateways and NAT gateways, you have it at one place. We did a lot of work on this with our AWS professional services team to find out the references, find out what customers are doing and how feasible this thing is. It's a pretty advanced networking model which we just implemented. And one thing I would say, whether it's a cross-region resiliency or multi-account or network, is very critical lessons that I can share with you. The amount of time we spent in the blueprint, in the design, in the evaluation is significantly more than the amount of time it takes to actually build it. And the reason the amount of time to build it is less is because automation and infrastructure as a code. Before I close my session, this is some interesting slide that we are running a very important and interesting initiative, such as providing AWS service catalogs to our customer for self-service and enabling themselves. Infrastructure as a code adoption, a big deal, a big foundation for all our projects, whether it is multi-account or whether it is DR. Infrastructure as a code is the foundation. And then we are expanding our disaster recovery to complex applications. Our end goal is make sure my internal customers are self-service enabled. So great things happening. We enjoy what we are doing here, and this team takes, my team and myself, we take a lot of pride in cloud enabling this country's mission critical railroad network. And I hope in last 25-30 minutes I could cover some use cases and advanced use cases. But thank you very much for your time, and I will listen to your use cases in this summit as well. With this, have a nice day.
Shrikant, thank you very much for that overview. I love the way that Amtrak is continuing to iterate and grow. You're utilizing AWS to expand your operations. You're taking things that are already a great customer experience and improving that. You're taking a very, very safe ridership experience and you're making it safer. Thank you for utilizing AWS, and thank you for serving the public.